Okay, let's unpack this. Um, you've been building React apps in JavaScript for a while now, right? And you've probably seen the question popping up everywhere. Should I learn React with TypeScript or JavaScript? It
Yeah.
feels like this big decision just, hanging out there.
It absolutely is, and the conversation around it can get pretty passionate sometimes.
It really can. We recently came across this article on DV Community, TypeScript to know for React. And wow, the author's a very strong take.
Yeah.
They even say it breaks my heart to see React developers still sticking purely with JavaScript. They feel they're making their life harder.
That's a bold statement, but I bet they back it up somehow.
They do immediately.
Yeah.
With a pretty compelling promise, actually. They say the time you spend wrapping your head around TypeScript will 100% pay off in the time you save debugging weird bugs.
Okay, less time debugging, less hair pulling over runtime errors. That definitely sounds like a deal worth investigating.
Right. So the mission for this deep dive, pulling directly from this article, is really to cut through the noise. We want to understand the core arguments why TypeScript is presented as such a valuable upgrade, specifically for React folks, and get just enough insight into how it fundamentally works, without getting totally lost in the weeds.
And figure out the specific concepts and patterns from the article that you'll actually use day to day in a React project. Make it clear.
Exactly. Think of it as extracting just the essentials guide the author offers.
Right. We're aiming to give you, the listener, a clear picture of the key benefits and sort of the minimal knowledge required to maybe start integrating TypeScript into your existing workflow.
Yeah.
Or a new one.
Okay, perfect. Let's jump right into that why then. Given that promise of saving debugging time, what's the core reason TypeScript even exists, according to this article? And what are the specific benefits for React developers?
Right. So at its heart, the author explains TypeScript as basically just adding extra syntax on top of JavaScript. That's where you see the types like .string or .number. And the whole purpose is just to help you catch errors early.
Before your users see them. Super important.
Exactly. And crucially, it all compiles to JavaScript in the end. Your browser doesn't understand TypeScript itself.
Okay.
It's a build time tool. It helps you write more robust JavaScript before it ever hits the browser.
And something I found really reassuring kind of early in the article, and I think this is key for anyone feeling a bit overwhelmed, is the point that you can slowly migrate to TypeScript.
Oh, that's huge.
Yeah, it's not like this massive all-or-nothing rewrite. You can literally take it file by file, component by component.
Which, drastically lowers the barrier to entry, right? It makes it feel much more doable.
Totally.
So, okay, let's look at those specific benefits the author calls no-brainers.
Right. The first big one, catching bugs before they hit production. The article uses this great, really relatable example, a simple JavaScript function, print first char. It takes an array of users, just strings, and an index. And it tries to print the first character of the user at that index.
Okay, sounds simple enough.
The JS code looks totally innocent. Const name users user index console.log name 0. But what if you accidentally pass an index that doesn't exist?
Like the array only has 2 users and you ask for index 5.
Exactly. You call print first char users 5 and bang, runtime error. Cannot read properties of undefined. And that only happens when the code actually runs.
Could be hours, days later, or worse, for a user in production. Ouch.
Right. But with the TypeScript version, you add types. You say users a string, an array of strings, and user index is number.
Okay.
Now, TypeScript doesn't magically make users 5 exist, obviously, but before you even run the code, your editor, powered by TypeScript, looks at user's user index.
And it knows that accessing an array index might return undefined.
Exactly. It sees that name might be undefined and gives you an immediate warning right there in your code editor. Like, hey, this name variable might be undefined-o, and you're trying to access property 0 on it.
So instead of a runtime crash later...
You see that little squiggle while you're coding? It prompts you right then and there to add a check, like it name null or something.
That's a massive shift left, finding issues way earlier. Huge difference. It catches whole classes of errors, like null pointer exceptions, basically, before they even leave your machine.
Totally. Benefit number 2 they list, getting autocompletion with libraries.
Oh, this is a big one for productivity. If a library provides TypeScript types, and honestly, most popular ones do these days.
Your editor suddenly gets super smart about that library.
Precisely. You type the name of a library variable, hit the dot key, and boom, you see all the available methods and properties right there.
It's like having the documentation baked right into your coding experience.
Exactly. Exploring a new library becomes way faster, and even remembering the API of familiar ones is just effortless. It smooths out the whole development flow. It really does.
Definitely see the appeal there. And the third, no-brainer benefit, making your code more resilient to changes over time.
Yeah, this one's interesting. The article uses a getLabel function example. It takes a status string, maybe idle, loading, success, and returns a display label using a switch statement.
Okay. Standard stuff.
In plain JavaScript, right. Now imagine months down the line, someone on the team adds a new status value, say error, and they pass error to this function.
But they forgot to update the switch statement inside getLabel.
Exactly. So the JavaScript function just silently returns undefined, no JS error, nothing breaks immediately, just weird behavior pops up somewhere else in the app later.
Ugh. Hunting down those silent undefined returns is the worst.
Yeah.
So frustrating.
Totally. But the TypeScript approach is different. You define the allowed status values explicitly using what's called a union type. Type status equals idle, loading, success.
Okay, so status can only be one of those three strings.
Right. Now, if someone later adds error to that static definition type status idle loading success error, TypeScript immediately looks at your getLabel function that accepts status.
And it sees the mismatch.
Yep. It basically says, hey, you're telling me this function can now receive error, but your switch statement doesn't handle it. It flags it right away.
It actually yells at you, as the article says. Like gives you a compiler error.
Yeah, something like, not all code paths return a value, which is exactly what you want.
Absolutely.
It forces you, at the moment you update the type definition, to go and update the corresponding logic in getLabel. It prevents that future silent failure. It acts like a living contract for your code, catching inconsistencies caused by changes.
Okay, wow. The why is incredibly compelling. Faster bug catching, better editor support, code that breaks less when you change things later. I'm starting to see why the author feels so strongly.
It really does make a difference in practice.
But okay, if I'm a React developer, coming from JavaScript, maybe feeling a little intimidated, where do I even start with the TypeScript syntax itself? What are the absolute must-know foundational pieces according to this article?
That's the perfect transition. The article dedicates a whole section to just that, what they call the bare minimum concepts, to get you writing basic type-safe code without needing a PhD in type theory.
Bare minimum sounds good.
Okay, what's first?
First up, and maybe the most fundamental,
Yeah.
types themselves.
Right, the core thing.
Yeah. Types, as the article says, describe the shape of your data and enforce it. You start with the native JavaScript types you already know, like string, number, Boolean.
Okay.
And array types are just those followed by square brackets, like number for an array of numbers, string for strings.
Pretty straightforward so far. Feels familiar.
Right. And what's cool is that TypeScript is often quite smart. It can infer the type based on the value you assign. If you write const count 0, TypeScript just knows count is a number. You don't always have to explicitly write number.
Ah, okay. Less typing sometimes.
Yeah.
Yep.
But you often do need to define more complex shapes, especially for objects which are everywhere in React, right? Props, state.
And that's where custom types come in, using the type keyword. Exactly. You use the type keyword to define the structure, the blueprint, for an object. The article's user example is perfect. Type user equals ie.number, name.string.
Okay.
Now, whenever you declare a variable or a prop as type user, TypeScript will check that it actually has an id property that's a number and a name property that's a string. Try to assign a number to name. TypeScript complains immediately.
Gotcha. Defining the structure is key. What's another really critical point the article makes?
A huge warning sign the author puts up. Avoid any. They are very, very firm on this. Quote, unless you're in the middle of a migration, don't use any.
Ooh.
Yeah.
Okay. Why is any the big bad wolf here?
Because, as the article puts it, it's essentially JavaScript in disguise. When you type something as any, you're basically telling TypeScript, hey, step back. Don't check this. I know what I'm doing.
So you completely opt out of the type checking.
You opt out of the very thing TypeScript is designed to help you with. You lose all those benefits we just talked about, the early bug catching, the autocompletion.
Yikes. Okay. So if not any, what do you use when you genuinely don't know the type? Or it could be multiple things.
The article suggests unknown as a much safer alternative.
Unknown. How's that different?
Well, when a variable's type is unknown, TypeScript still forces you to check its type before you can actually do anything specific with it. The log length example shows this really well.
Okay.
If you have log length value.any, TypeScript lets you try to call value.length even if you accidentally pass in a number, which crashes at runtime. But log length value.unknown.
TypeScript stops you.
It gives you a type error if you try to access .length directly on value. It forces you to add a check first, like if the type of value, string array, .ascii array, value.lag, value.length. You have to prove the type before using it.
Okay. So unknown makes you explicitly handle the uncertainty, be safe about it, whereas any just sweeps it under the rug until it potentially blows up later.
Exactly. And the article also shows an even better option sometimes. If you know the value should be one of just a few specific types that do have a .length property.
Like a string or an array.
Right. Then you can use an explicit union type, like string array like unknown. This communicates your intent much more clearly while still being safe.
Got it. Avoid any like the plague. Be explicit with types or use unknown when you truly need to check the type first. What about combining types? You mentioned union types.
Yep, that's where union and intersection types come in. Unions, using the pipe symbol, let a value be one of many types. Our status example from before is perfect. Type status equaled idle loading error. A variable of type status can only hold one of those three exact string values, nothing else.
That seems incredibly useful for things like state machines or preventing typos and string constants.
It really is super powerful for that. Then you have intersections using the ampersand. They let you combine multiple types into one.
Okay.
The article shows how you can define type name, name docs, string, and type age. Then you create type person, name and age.
So a person has to have both a name and an age.
Exactly. A variable of type person must have both the name property string and the age property number.
Okay, so unions are like an OR for types, and intersections are like an A and D. Makes sense. Clear.
Yeah.
The article also introduces interfaces. How do they fit in?
Right. Interface are another fundamental way to define the structure of an object. For defining object shapes, honestly, they're very similar to using the type keyword we just discussed.
Yep.
Yeah, the example interface, username.string, age.number, it looks almost identical, in effect, to the type user version for simple cases.
So for these basic use cases, like defining props maybe, is there a big difference between using type and interface?
For the core concepts covered here, and for typical React component props and state, the author basically says, it doesn't matter much. You'll see both used.
Okay.
There are deeper technical differences if you get into more advanced scenarios, and the article points out there are guides that dive into that. But for getting started, you can often use them interchangeably for defining object shapes.
Good to know.
A key feature of interfaces, though, that's worth mentioning, is that they can be easily extended using the extends keyword.
Like inheritance.
Kind of, yeah. For example, interface admin extends user role.string, creates a new admin interface that automatically gets all the properties from the user interface, like name and age, and adds its own role property.
Okay, so interfaces are great for defining object shapes and then building upon them, creating variations.
Yeah.
Makes sense. What about when you have similar structures, but with different underlying data types?
That's the perfect setup for generics.
Generics. Okay, T. I've seen those.
Yep, usually T. The article frames them as a way to write reusable types with flexible data. The classic example they give is handling API responses.
Right.
Without generics, if your API returns different kinds of data, you might end up defining really repetitive types, like type user response, status.number, data user, error.string, and then type product response, status.number, data, product, error.string.
Right.
See the repetition?
Yeah, the status and error parts are identical. Only the data property is different, user in one, product in the other.
Exactly. Generics let you define a placeholder, that T, in your type definition, so you write just one. Type API response, A, status.number, data, T, error.string.
Okay, so T is the placeholder for whatever data type will be there.
Precisely. Now you can reuse this single API response definition for all your different data types. Type user response, API response user, or type product response, API response product. When you use API response, you just tell it what T should be in that specific case.
Okay, so T is like a variable, but for the type itself. The analogy in the article is pretty good. I like to think of generics like function parameters, but for types A.
It really helps it click, doesn't it? And generics aren't just for type definitions like isate response. You'll see them used in functions too, especially utility functions or library code. Like a function wrap, value.t. This function could take a value of any type T, a string, a number, a user object, and it returns an array of that same type T. It figures out the return type based on what you pass in.
Very cool. Super flexible for writing reusable code. Okay, what's the last foundational concept from the article's bare minimum list?
The last one is typing functions themselves, defining the types for function parameters, and importantly, their return values.
Okay, how does that look?
For parameters, it's simple. You just add the type after the parameter name with a colon dot add a number, b number.
Right.
For the return type, you add a colon and the type after the parameter list, but before the opening curly brace of the function body function add, a number, b number,
Right.
number return a plus b.
Okay, so that explicitly says this add function takes two numbers and must return a number.
Exactly. Now, what if you don't explicitly type the return type?
Does Typescript guess?
Often, yeah, it can infer it pretty well based on what the function actually returns. If you just return a plus b, and a and b are numbers, it knows the result is a number.
So is it always necessary to write the return type?
Not strictly necessary if it can be inferred easily, but the article gives some solid advice here. When in doubt, type the return type.
Why is that?
It just makes the function's intended output crystal clear. It acts as another form of documentation, and more importantly, a safety check. If you later refactor the function and accidentally make it return something else, Typescript will immediately tell you it no longer matches the declared return type.
Ah, catches refactoring errors too. Nice.
Yeah. And you can also type a function variable itself, like when you assign an arrow function to a constant const add a number, b number, number a, b equals a plus b. This syntax explicitly declares the exact signature the function stored in add must match.
Okay, got it. So those 6 concepts.
Yeah.
Basic type, string, number, etc. Avoiding any, using unknown or specific types instead. Combining types with unions and intersections. Defining object shapes with interfaces or types. Using generics, T, for reusable types. And explicitly typing function parameters and return values.
Yeah.
That actually feels like a manageable set to get started with.
Right. It's not about learning the entire language spec up front. It's about grabbing these core tools first.
So now the big question. How do these actually apply day to day when you're sitting down writing a React component in a .tsx file?
This is where you bring those core concepts directly into the React patterns you already know and use every day. The article walks through the most common ones.
Like props, probably the most common thing.
Absolutely. And the article keeps it simple. Props are just objects. Type them like any other object.
Okay.
So you define the shape of the props your component expects using either a type definition or an interface. Like type greeting props, name.string, message.string. That question mark makes message optional, by the way.
Oh, good tip.
Then, in your functional component, you just apply that type to the props parameter, const greeting props, or you can destructure it with a type, const greeting message greeting props.
Okay, so the props object is just another object whose structure you're defining and enforcing with TypeScript types. Makes total sense. What about state.useState?
UseState is a perfect example of a hook that uses generics, that T syntax. Often, though, TypeScript is smart enough to infer the state type from the initial value you provide.
Oh, yeah.
Yeah. If you write useState, TypeScript correctly infers that the state variable will be a number and the setter function will expect a number. If you do useState, it infers string.useState, it infers Boolean.
Okay, so for simple cases, it just works.
Pretty much. But where you do need to be more explicit is when the type is more complex, or when the initial state might be null or an empty array where the type isn't obvious yet.
Right. Like if you have state that holds user data, but it starts as null.
Exactly. That's a classic case. You'd provide the type explicitly using the generic parameter useState id.number name.string null. That union type null is crucial here. It tells TypeScript that the state can either be an object with id name or it can be null.
Got it. So use explicit types for useState when you have complex state shapes or unions like maybe null or maybe empty arrays that will eventually hold specific things like useState user.
Precisely. It gives TypeScript the information it needs right from the start.
Okay. What about just regular variables and functions you define inside a component's body?
The article says it simply, just like normal TypeScript. Variables you declare within your component function follow the standard rules. They're inferred if possible.
Like const loading, true, is inferred as Boolean.
Yeah. Or you type them explicitly if needed, especially for more complex types or empty arrays. Const user list.
And functions inside the component. like event handlers.
Same idea. You type their parameters. And the article gives a really great practical tip here, especially for standard DOM events like clicks or changes.
What's that?
Just hover over the element itself in your JSX, like hover over the on-click prop on a button in VS Code, for instance.
And the editor tells you the expected type.
Usually, yeah. It'll pop up a little tooltip showing that on-click expects a function compatible with something like React mouse event HTML button element.
Whoa, that's super helpful. No need to memorize all those event types.
Exactly. So you just grab that type and use it for your handler functions parameter, const handle click click equal event, react.mouse event HTML button element.
Or if you define the handler separately.
You can type the variable itself using a slightly different event handler type. Const handle click react.mouse event handler HTML button element. The editor tooling really makes finding and using these specific event types much easier than it sounds.
That's a relief. Okay, how about reusing types? Say you have several components that need similar props, maybe different kinds of buttons.
Definitely want to avoid duplication there. This is where those type and interface definitions, especially interface with its extends keyword, really pay off.
Ah.
The article shows examples. You could define a base interface button props on click, avoid children React node. Then for an icon button, you define interface. Yeah. Icon button props extends button props icon.string.
So icon button props automatically gets on click and children from button props.
Correct. It inherits them. Or if you prefer using type, you could achieve the same thing with an intersection type. Type icon button props and pattern ref. Both methods help you keep your type definitions DRY. Don't repeat yourself.
Nice. Okay, finally, hooks, both the built-in React ones and custom hooks you might write. How do types apply there?
Well, pretty much all the native React hooks, the ones built into React itself, were designed with TypeScript in mind. Most of them accept generic parameters.
We saw useStat_0. What else?
UseRef is another really common one. You typically specify the type of the DOM element it's going to reference and often initialize it to null. Use ref HTML impute element, null. That tells TypeScript this ref is meant to hold a reference to an input element or be null initially. Yep. And useReducer also heavily uses generics to let you specify the exact shape of your state and the types of actions your reducer can handle.
Got it. What about custom hooks that we write?
Simple. Since a custom hook is fundamentally just a function, it just happens to call other hooks inside it. You type it exactly like any other function.
So define the types of its parameters and its return value.
Exactly. The article has a useTopple example. It's a custom hook that returns a Boolean state value and a function to toggle it. So its return type is explicitly typed as a tuple. Boolean, the void.
Ah, a tuple. So it clearly signals it returns exactly two things, a Boolean and a function that takes no arguments and returns nothing, void.
Precisely. It makes the contract of your custom hook very clear to anyone using it.
Okay, wow. So it really boils down to applying those fundamental TypeScript concepts we discussed earlier, basic types, functions, generics, unions, interfaces, avoiding any to the specific patterns you already know and use in React, typing the objects for props and state, typing your components' internal variables and event handlers, leveraging generics and hooks like useState and useRef, and reusing type definitions with extends or intersections.
You got it. That really covers the bare minimum that the article argues you need to actually start doing TypeScript effectively in a React project. It's about applying those fundamentals to the React context.
This has been incredibly valuable for getting a handle on those essentials. Feels much less daunting now. But obviously, as the article implies, that's just the starting point, the bare minimum. Yeah. If someone's listened to this, they're feeling okay about these basics and they're ready to go deeper.
Yeah.
Where does the article suggest they look next?
Yeah, the author provides a really fantastic list of resources for continued learning, acknowledging this was just the intro. They strongly recommend the TypeScript official docs as the absolute best place to start.
Makes sense. Go to the source.
They highlight that the official docs are clear, well-written, and have that interactive playground right in the browser, which is great for experimenting.
Okay, official docs first. What about more React-specific TypeScript learning?
For that, Total TypeScript gets a big shout-out. Apparently, it has fantastic resources, especially Matt Pocock stuff. There's a mention of a free beginner course and materials on more advanced patterns tailored specifically for React developers.
Oh, nice. React-focused is good.
And also, the React TypeScript cheat sheets are mentioned. Sounds like a great beginner-friendly, quick reference for common React patterns and how to type them, like a handy lookup guide.
Okay, those sound practical.
Yeah.
What about resources for just improving the quality of your TypeScript code,
Yeah.
like beyond just making it compile, writing good TS?
Good question. The article points to two things there. One is the TypeScript style guide, which sounds like it offers short, practical tips for writing cleaner, more idiomatic TypeScript code, like conventions and best practices.
Sort of like a linting guide, maybe.
Could be, yeah. And then there's a book or resource called Effective TypeScript, which apparently goes into more advanced techniques and patterns for writing better, more robust, more maintainable TypeScript, moving beyond the basics.
Okay. And for people who like to learn by, like, doing puzzles.
Yeah, they mentioned type challenges. Sounds like a collection of TypeScript puzzles designed to test and sharpen your skills with the type system itself. Could be fun, or maybe maddening.
Huh. Depends on the person, I guess. But that's a really comprehensive roadmap, isn't it? From the official beginner fundamentals all the way to advanced techniques, style guides, React-specific resources, and even challenges.
It really covers all the bases, yeah. Depending on how far down the TypeScript rabbit hole you eventually want to go, gives you plenty of next steps.
So, okay, bringing it all back then, wrapping up our deep dive into this DV community article. The core message, the main argument, feels pretty undeniable based on what they presented. Using TypeScript with React is positioned as a really significant, worthwhile upgrade.
Yeah, absolutely. And the primary reasons they hammer home are, one, it fundamentally helps you catch bugs early, shifting that debugging effort from runtime when users might see it to compile time when only you see it.
Right, huge win.
Two, it provides that much better tooling experience, the auto-completion and error checking right in your editor, making development faster and smoother. And three, ultimately, it makes your code easier to maintain and more resilient, less likely to break silently as your project evolves and changes over time.
And I think, for me, maybe the most empowering takeaway, especially for JavaScript developers looking at TypeScript for the first time, is that reassurance we talked about. You don't need to learn everything up front.
Absolutely key.
You really can just start with those bare minimum concepts we walked through. Understanding basic types, using interfaces or types for objects, recognizing generics when you see them in hooks, typing functions. You can gradually layer in more complexity as you encounter the need for it.
It's absolutely not this giant monolithic thing you have to conquer all at once to get started, which is great. I loved that analogy the author apparently shared in the comments section of the article, comparing learning TypeScript for React to putting training wheels on a new bike.
Oh yeah, that was good. It makes the initial ride smoother, right? And you definitely fall less off and hit fewer of those runtime errors.
Yeah.
Exactly. And the nice part is, as someone joked back in the comments, unlike with a real bike, where you eventually take the training wheels off, with TypeScript, you can effectively leave them on. They just keep making your code safer and your development process smoother indefinitely.
Huh. That's a perfect analogy for the ongoing benefits, actually. It just keeps helping.
It really does seem that way.
So, final thought then, building on all this. If adding TypeScript really does help catch so many errors before they ever run, if it makes refactoring feel less risky because the compiler checks your work, and if it significantly boosts your editor's ability to understand your own code, what could the long-term cumulative effect of all that be? Not just on your individual productivity, maybe, but on the overall confidence and perhaps the velocity of an entire development team working together on a code base over time.
That's a really interesting question to ponder. What's that compound effect?
Yeah, something to chew on as you think about whether bringing TypeScript into your own React projects might be worth that initial learning curve.